Starting with the topic hemostasis and blood coagulation. So it has this first topic, that is events in hemostasis. Let's see what it says. The term hemostasis means prevention of blood loss. Whenever a vessel is severed or ruptured, hemostasis is achieved by several mechanisms. The first one is vascular constriction. Second one is formation of a platelet plug. Third is formation of a blood clot as a result of blood coagulation. And the fourth one is eventual growth of fibrous tissue into the blood clot to close the hole in the vessel permanently. So what does this mean? Let's see. This paragraph is wanting you to know that if this is my blood vessel, whenever it gets ruptured like this, it follows certain mechanisms. The first one is vascular constriction. The second one is platelet plug formation. The third one is blood coagulation. And the fourth one is fibrous tissue formation. Let's see the first event, and that is vascular constriction. Let me read it first. Immediately after a blood vessel has been cut or ruptured, the trauma to the vessel wall causes the smooth muscle in the wall to contract. This instantaneously reduces the flow of the blood from the ruptured vessel. The contraction results from local myogenic spasm, local autocoid factors from the traumatized tissues and blood platelets, and nervous reflexes. The nervous reflexes are initiated by the pain nerve impulses or sensory impulses that originates from the traumatized vessel or nearby tissues. However, even more vasoconstriction probably results from local myogenic contraction of the blood vessels initiated by direct damage to the vascular wall. And for the smaller vessels, the platelets are responsible for much of the vasoconstriction by releasing a vasoconstrictor substance thromboxane A2. Hmm. So, what exactly this paragraph means? So, this means that the first process, which is the vascular constriction, what does it mean? So, in the blood vessels, we have something called as smooth muscles. Okay? They are there in the blood vessels, in the layers of the blood vessels. So, whenever the vessel ruptures, it contracts, and then the picture looks like this. The contraction occurs. Okay? And when contraction occurs, what happens is the vessel wall, which was ruptured, can you see now the width has reduced? Sorry, the width has been reduced. So this is the first mechanism. The width is reduced, the flow of the blood outside will also reduce. So this is the first mechanism. This is the first mechanism of vascular constriction. Means vascular means blood vessel, constriction means पतला हो जाना, और you can say कंस्ट्रिक्ट हो जाना. सो उसका पहला मैकेनिज्म क्या है? लोकल मायोजेनिक स्पाज्म, यानी लोकली आसपास जो ये स्मूथ मसल्स हैं, दे विल कॉन्ट्रैक्ट एंड दे विल constrict the blood vessel. The second mechanism is local autocoid factors released from the blood platelets. Now, inside the blood vessel, we have these platelets, and they release certain autocoid factors, which also helps in vascular constriction. The third mechanism is, now there are certain nerve endings. There are certain nerve endings in this blood vessels, which will get stimulated. Okay, when the blood vessel ruptures, they also get irritated. The pain receptors are there; they will also get irritated, and they will generate a nerve reflex that will also help in vascular constriction. So these are the three mechanisms by which the vessel constricts, and that's the first event in hemostasis, as we have learned previously. Hemostasis is followed by, hemostasis, the event of hemostasis, the first event is vascular constriction, and that we have seen. Now the next process is formation of a platelet plug. Okay, platelet plug. So if the cut in the blood vessel is very small, indeed many several small vascular holes do develop throughout the body each day, the cut is often sealed by the platelet plug rather than a clot. So there is a difference between a plug and a clot. So the first event was vascular constriction. Let me annotate that. So, so the first event was vascular constriction. Done. Okay. Now the second event is formation of a platelet plug. Let's see. What is the mechanism of the platelet plug? Platelet repair of vascular opening is based on several important functions of the platelet. When platelets come in contact with a damaged vascular surface, especially with collagen fibers in the vascular wall, the platelets immediately change their own characteristics drastically. They begin to swell, they assume irregular forms with numerous irradiating pseudopods protruding from their surfaces. Their contractile proteins contract forcefully and cause the release of granules that contain multiple active factors. They become sticky and they adhere to collagen in the tissues and to the protein called as von Willebrand factor that leaks into the traumatized tissue from the plasma. They secrete large quantities of ADP and their enzymes form thromboxane 8. The ADP and the thromboxane in turn act on nearby platelets to activate them as well, and the stickiness of these platelets cause them to adhere to the original activated platelets. Let us see what this paragraph means, that is mechanism of platelet plug. Let's make again a blood vessel. Suppose that this was my blood vessel and it has ruptured, and now the first event, that is the vascular constriction, has happened. The vascular constriction has happened, and now I have these platelets inside. Okay, not visible. So these platelets are there. Normally, these platelets will move inside the blood vessel, but now the blood vessel is ruptured. So how the platelet plug is formed? The platelet plug is formed in the following manner. When the blood vessel is ruptured, the platelets see that there is collagen exposed. So whenever the blood vessel is ruptured, the collagen, let me introduce collagen here. Suppose the collagen is here. This is the collagen. So they will see the collagen and they get attracted towards collagen, and they gets into this shape. Once they become like this, they become irregular, they release certain molecules, they release granules, etc. And they attracted towards the collagen and they go and attach to this collagen molecule. They go like this and they attach to the collagen molecules which are exposed because of the ruptured blood vessel. Now what happens? Along with the granules, they also release ADP, they also release thromboxane A2. These two molecules, that is ADP and thromboxane A2, they will attract other platelets which are here in the periphery. They will say these platelets to come with us and form a plug. So they will also join, and hence a platelet plug is formed like this. So this is the platelet plug formation. Now, most of the cuts or small blood vessels when they ruptured, this is the mechanism which is the major contributor. But when the blood vessel is of a bigger diameter, or we can say it is severely injured, then this mechanism, that is the first vascular constriction and the second platelet formation itself or alone, is not sufficient. So what it does is the third mechanism, which is called as coagulation, which is causes blood coagulation. So this is the paragraph: blood coagulation in the ruptured vessel. So let's see. The third mechanism for hemostasis is formation of the blood clot. The clot begins to develop in 15 to 20 seconds if the trauma is severe, and in 1 to 2 minutes if it is a minor. तो अगर छोटा सा कट है तो blood coagulate होता भी नहीं है. It is only the platelet plug which is the main contributor. लेकिन अगर severely injured है, then blood coagulation has to happen. Now blood coagulation कैसे होता है? The blood coagulation is initiated by these clotting factors. For example, fibrinogen, prothrombin, factor number 5, 6, 7, 9, 10, 11, 12. All these and their synonyms are also given. These clotting factors, where do they come from and where are they? So they are inside your blood vessel only. They are present inside your blood vessel. They are inside your blood vessels. These factors are inside your blood vessels. They come inside the blood vessels with the help of liver. The liver synthesizes these factors and then it come into the blood vessels, and they're normally there. But when the blood vessel ruptures and it gets severely injured, these factors get activated and they form a platelet. No, now they form a blood coagulation. So now the process of coagulation starts. That's the third mechanism. And the fourth mechanism is organization or dissolution of a blood clot. So once a blood clot has formed, it can follow one of two courses. Suppose that in this, let me show you the blood. Suppose the coagulation has happened, and now coagulation has happened and the clot has been formed. Now what will happen? Now there are two ways to do it. Now it has been formed and it will dissolve on its own like this. It will dissolve, and a normal blood vessel is formed like this. This is the first thing. Or second, there is a formation of a fibrous tissue over that clot. These are the two ways. That's how a clot further contributes. So let's see the paragraph. Once a blood clot has formed, it can follow one of the two courses. It can become invaded by fibroblast, which subsequently forms connective tissue all throughout the clot, or it can dissolve. Okay. Now let's see the mechanism of blood coagulation. What is the basic theory? More than 50 important substances that cause or affect blood coagulation have been found in the blood and in the tissues. Some that promote coagulation, called as procoagulants, and the other that inhibits the coagulation, called as anticoagulants. Whether blood will coagulate depends on the balance between these two groups of substances. In the bloodstream, the anticoagulants normally predominate, so the blood does not coagulate. But when the vessel is ruptured, the procoagulants from the area of the tissue damage becomes activated and overrides these anticoagulants, and then a clot does develop. Now let's see further picture of this. This was your blood vessel. Again, ruptures. The first mechanism, vascular constriction occurs. Second mechanism, platelet plug occurs. Third mechanism we are seeing in detail, that is coagulation. So normally I have already told you that normally there are these factors, ठीक है, which promotes coagulation. और इसके साथ साथ एक और होते हैं anticoagulant factors, anti factors, which we say they are also there. Why they are important? Because normally your blood doesn't coagulate. Normally your blood flows. Normally your blood flows. It doesn't coagulate. Why? Because your anti factors are predominant and your coagulating factors they are lesser. So blood flows. But let's see what happens when the blood ruptures. When the blood ruptures, then what happens? Then these anti-factors decrease. These anti-factors they decrease, and my coagulating factors they will increase. And hence the coagulation process starts. That's what it means. Let's see the general mechanism now. Clotting takes place in three essential steps. Again, let's see. The first step. In response to rupture of the vessel or damage to the blood itself, a complex cascade of chemical reactions occurs in the blood involving more than a dozen blood coagulation factors. The net results of all this is formation of a complex of activated substances collectively called as prothrombin activator. The second step, the prothrombin activator, catalyzes the conversion of prothrombin into thrombin. The third step, the thrombin acts as an enzyme to convert the fibrinogen into fibrin that enmeshes the platelets, blood cells, and plasma to form the clot. Let me explain this to you with this diagram. Yes. Or you can see on the right hand side as well. I'm explaining how the actual coagulation process starts. So this was the blood vessel again, and this ruptures, and now the first step happens, second step happened, now the third step is to form a clot. So बहुत सारे जो factors which I have told you कि जो blood vessels में already flow कर रहे थे अब वो activate हो जाते हैं क्योंकि blood vessel rupture हो गई है. अब वो फैक्टर्स एक दूसरे को एक्टिवेट करते जाएंगे. बहुत सारे फैक्टर्स है, लाइक देयर आर सो मेनी फैक्टर्स, 6 7 8 9. वो एक एक करके पूरा एक कैस्केड बनता है और सबको मतलब सपोज इफ दिस इज वन फैक्टर, ये आगे वाले को स्टिमुलेट करता है, फिर तीसरे वाले को स्टिमुलेट, ऐसे करते करते द कैस्केड रन्स. और फाइनल एक पॉइंट आता है जब वी हैव दैट फैक्टर. Which factor we are talking about? See here, the factor that is prothrombin activator. तो ये कैस्केड तब तक चलता है जब तक प्रोथ्रोम्बिन एक्टिवेटर नहीं आता. प्रोथ्रोम्बिन एक्टिवेटर, नाउ सी ऑन द लेफ्ट साइड, आई विल एनोटेट फॉर यू. तो जब तक प्रोथ्रोम्बिन एक्टिवेटर नहीं आता तब तक ये कैस्केड चलता है. जैसे ही प्रोथ्रोम्बिन एक्टिवेटर आता है और वो प्रोथ्रोम्बिन को एक्टिवेट करता है, उसके बाद तो ये है प्रोथ्रोम्बिन एक्टिवेटर, इसने प्रोथ्रोम्बिन को एक्टिवेट किया, इसमें कैल्शियम भी इंक्लूड होता है, एंड नाउ द थ्रोम्बिन इज फॉर्म्ड. नाउ व्हाट विल हैपन, दिस थ्रोम्बिन व्हिच इज फॉर्म्ड will convert another factor, that is fibrinogen, into fibrinogen monomer. Again, this fibrinogen monomer with the help of calcium forms fibrin fibers, and then with the help of fibrin stabilizing factor the cross linking happens, fibrin fibers form, clot is formed. That's how the process runs. So majorly for the clotting pathways there are two major pathways. दोनों ही pathways में पहले जो factors होते हैं वो different है, and they form a cascade, and until they reach to this step which is the prothrombin step. इसके बाद का पूरा जो step है दोनों ही पाथवेज में सेम है, एंड दोनों ही pathways led to the formation of cross-linked fibrin fibers, and that's how the clot is formed. You will understand it more further. Let's see. Thus it forms. Now let us see the conversion of prothrombin to thrombin in detail. So first, prothrombin activator is formed as a result of rupture of blood vessel, as a result of damage to special substances in the blood. ठीक है. Second, the prothrombin activator in the presence of calcium causes conversion of prothrombin to thrombin. I have already told you. Next. Third is the thrombin causes the polymerization of fibrinogen molecules into fibrin fibers within 10 to 15 seconds. Thus, the rate limiting factor in causing blood coagulation is usually the formation of prothrombin activator and not the subsequent reactions beyond that point, because these terminal steps normally occur rapidly to form the clot. So, very important, ये जो process है, which process conversion of or not conversion but formation of prothrombin activator. Let's see this step. If you can see, दिस फॉर्मेशन इज द रेट लिमिटिंग स्टेप. यही स्टेप बहुत स्लो होती है, बाकी सभी स्टेप्स बहुत रैपिड होती है, इसलिए इसको हमने रेट लिमिटिंग स्टेप बोला है. जब ये बनता है उसके बाद प्रोथ्रोम्बिन थ्रोम्बिन बनना, फिर थ्रोम्बिन फाइब्रिनोजन को फाइब्रिनोजन मोनोमर में, एंड देन द क्रॉस लिंकिंग हैपेंस. Okay, let's view it now. Do platelets have any role in clotting? Let's see. In the last para it is written, platelets also play an important role in the conversion of prothrombin to thrombin, because much of the prothrombin first attaches to the prothrombin receptors on the platelets already bound to the damaged tissues. Ab, the story is this कि already we have this platelet plug, ऐसे करके ये platelet plug जो था second step. अब इस प्लेटलेट्स के ऊपर एक और रिसेप्टर है. लेट मी ड्रॉ द रिसेप्टर लाइक दिस. सो दिस इज द रिसेप्टर. द नेम ऑफ द रिसेप्टर इज व्हाट? इट इज प्रोथ्रोम्बिन रिसेप्टर्स. तो यहाँ पर ये सपोज लेट मी शो प्रोथ्रोम्बिन विद द हेल्प ऑफ पर्पल कलर. So this is the prothrombin. This is the prothrombin, and it gets attached to these receptors which are present on the platelets. ठीक है. So जब ये बाइंड होता है, ओनली देन द प्रोथ्रोम्बिन गेट्स व्हाट? इट गेट्स एक्टिवेटेड एंड इट गेट्स कन्वर्टेड इनटू थ्रोम्बिन. सो let me revise the steps. First is vascular constriction. Second is the platelet plug formation. Third is there is a prothrombin activator. We have seen उसने prothrombin activator को activate करना है एंड प्रोथ्रोम्बिन का कन्वर्जन थ्रोम्बिन में करना है. दैट इज वन थिंग. तो दो कैस्केड्स वी विल लर्न लेटर दैट देयर आर टू कैस्केड्स, वो रन होंगे और अल्टीमेटली क्या बनाएंगे? प्रोथ्रोम्बिन एक्टिवेटर. अल्टीमेटली दे आर गोइंग टू फॉर्म प्रोथ्रोम्बिन एक्टिवेटर. ये वाला एक्टिवेट होगा और फिर स्टेप आएगी दिस वन, प्रोथ्रोम्बिन का थ्रोम्बिन में, थ्रोम्बिन का फाइब्रिनोजन में, ऐसे स्टेप्स. बट यहाँ पर प्लेटलेट्स ऑल्सो प्लेज एन इम्पॉर्टेंट रोल, बिकॉज जब प्रोथ्रोम्बिन एक्टिवेट हो जाएगा, you have this prothrombin activator, it activates your prothrombin. See clearly, prothrombin activator जब बना उसने एक्टिवेट किया प्रोथ्रोम्बिन. प्रोथ्रोम्बिन जैसे ही एक्टिवेट हुआ, सॉरी बना, इट विल बाइंड टू प्लेटलेट्स और प्लेटलेट के साथ बाइंड होकर नाउ इट गेट्स कन्वर्टेड इनटू थ्रोम्बिन, which is this step, this whole step. तो कैल्शियम इज ऑल्सो नीडेड, और अगर मैं यहाँ पे क्लियरली लिखूँ तो यहाँ पे प्लेटलेट्स भी नीडेड है. सॉरी, प्लेटलेट्स भी नीडेड है, and that is the role of platelets in coagulation. Now let's see the next step. Prothrombin is a plasma protein and alpha 2 globulin. Again, having a molecular weight of 68,700. It is present in normal plasma in a concentration of about 15 milligrams. It is an unstable protein that can split easily into smaller compounds, one of which is thrombin. Prothrombin is formed continually by the liver and is continually being used throughout the body for blood clotting. If the liver fails to produce prothrombin in a day or so, prothrombin concentration in the plasma falls too low to provide normal blood coagulation. Vitamin K is required by the liver for normal activation of prothrombin as well as few other clotting factors. Therefore, either lack of vitamin K or the presence of liver disease that prevents normal prothrombin formation will decrease the level, and this will lead to bleeding tendencies. Okay, so they are explaining the importance. Let me show you what they are explaining here. They are telling what they are explaining is कि ये जो blood vessel है, again I've drawn it so many times. So, so, so. What I have explained, the vascular constriction, the platelet plug, and now the third step, we are in coagulation step. Coagulation step mein I have explained you that the factors, the coagulation factors are already present in the blood vessels. From where do they come? They come from the liver. And now they are saying that liver also needs which vitamin? Vitamin K to synthesize these factors, especially the prothrombin. And if so, whenever there is any liver disease or whenever there is vitamin K deficiency, we have learned this in previous classes that vitamin K deficiency leads to bleeding disorders. Okay, it will lead to bleeding disorders. Why it will lead to bleeding disorders? Now we have understood, because vitamin K is needed for the formation of a very important coagulating factor, and that is prothrombin. Because by the prothrombin, then the whole step of this will occur. Na? When prothrombin is formed, only then this whole step will occur, and that's how the coagulation will stop. Because normally in the body throughout a day there are many chances when your blood vessel get ruptures, but you don't get um, any symptom of it, or I want to say that you it automatically gets stopped, and you can even not see it because it's very deep inside the tissues. There are many organs or deeper tissues which can rupture also easily throughout a day, but that is not that gets coagulated because of prothrombin, normal levels of prothrombin in the body. But whenever there is liver disease or if there is vitamin K deficiencies, you will see bruising, you will see bleeding tendencies from the gums and all. That happens because normally जो clot हो रहा था वो नहीं हो रहा है, और daily there are chances of ruptures, और rupture हो रहे हैं, और अगर विटामिन के नहीं है, प्रोथ्रोम्बिन नहीं है, तो bleeding tendency will happen. That's the point here. Let's see now the further things. Now they are telling about conversion of fibrinogen to fibrin. That's the final process of formation of the clot. So fibrinogen is a high molecular weight protein that occurs in the plasma. Again, these factors all are proteins, and they are synthesized again by the liver. So here fibrinogen is formed in the liver, and liver disease can decrease the concentration of circulating fibrinogen as it does the concentration of prothrombin. Same है, अगर इसके भी levels कम होंगे तो again there is a bleeding tendencies will occur. Now, because of its large molecular size, little fibrinogen normally leaks from the blood vessels into the interstitial fluids, and because fibrinogen is one of the essential factors in the process, interstitial fluids ordinarily do not coagulate. Yet, when the permeability of the capillaries becomes pathologically increased, fibrinogen does then leak into the tissue fluids, allow clotting and allow clotting of these fluids in the way that plasma and whole blood can clot. So they are just telling कि ये जो fibrinogen है, कि it gets leaks into the interstitial fluid and it does not coagulate normally. The coagulation only happens whenever there is a rupture of any tissue or any blood vessel. Only there it functions. So it is there in the interstitial tissues, but it do not coagulate. But whenever the inside the blood vessel, whenever there is any rupture happens, जब तक rupture ही नहीं होगा तो वो बाहर कैसे निकलेंगे? This is the meaning of it. So they are there inside the blood vessels. They are there inside the blood vessels, but they are not able to coagulate. Why? Initially, I have told you because एक तो एंटी फैक्टर्स है, दोनों बराबर है और एक्चुअली एंटी फैक्टर्स ज्यादा है, सो दे डू नॉट कोएगुलेट. दूसरा, रप्चर ही नहीं हुआ है, कोलेजन विजिबल ही नहीं है. वो तो है कि प्लेटलेट्स विल बाइंड, बट अगेन विजिबल ही नहीं है, और ऑल्सो रप्चर भी नहीं है, तो वो लीक भी नहीं करेंगे, और वो लीक नहीं करेंगे तो वो कोएगुलेट भी नहीं करेंगे. दैट्स द रीजन व्हाई नॉर्मली दे डू नॉट कोएगुलेट. Now let's see this further steps. Action of thrombin on fibrinogen to form fibrin. Thrombin is a protein enzyme with weak proteolytic capabilities. It acts on fibrinogen to remove 4 low molecular weight peptides from each molecule of fibrinogen, forming one molecule of fibrin monomer that has the automatic capability to polymerize with other fibrin monomer molecules to form the fibers. Therefore, many fibrin monomer molecule polymerizes within seconds into long fibers that constitutes the reticulum of a blood clot. तो हमें exactly एक clot बनाना है. तो नेक्स्ट जो लास्ट स्टेप है थ्रोम्बिन का, एक्शन ऑफ थ्रोम्बिन ऑन फाइब्रिनोजन, जो ये वाली लास्ट स्टेप है, एक्शन ऑफ थ्रोम्बिन ताकि फिब्रिनोजन कन्वर्ट हो सके मोनोमर में. वो ऑटोमेटिकली मोनोमर मतलब कि लेट मी टेल यू, एक सिंगल मोनोमर, फिर दूसरा, फिर तीसरा, ऐसे ये चलते ही रहता है. इट हैज द कैपेबिलिटी, ये सिंगल फाइब्रिनोजन फिब्रिन मोनोमर है, वो ऑटोमेटिकली पॉलीमराइज होता है और अल्टीमेटली वी हैव अ क्लॉट रेडी. नाउ लेट्स सी नाउ फर्दर क्या होता है. In the early stages of the polymerization, the fibrin monomer are held together by weak non-covalent hydrogen bonding, and the newly forming fibers are not cross-linked with each other. As a result, the clot is weak and can be broken apart with ease. मतलब अभी ये बने हैं बट इनके बीच में जो बॉन्ड है is a weak bond and they are also not cross-linked. So what will happen? This is a weak structure. This is a weak structure. So now what will happen? Let's see. In this structure, this is a weak and it can rupture easily. One monomer, second monomer, third monomer, fourth monomer, इसमें ये weak bonds बने हुए हैं and they are there. Now what will happen? Let's see. To strengthen, अब ये ऐसा तो नहीं रहेगा ना, इसको strengthen करना है. So what will happen? This involves a substance called as fibrin stabilizing factor that is present in small amounts in the normal plasma globulins, but is also released from platelets entrapped in the clot. अब ये फिर से मैं ड्रॉ कर रही हूँ ब्लड वेसल एंड आई एम शोइंग द प्लग, प्लेटलेट प्लग जो था ऑलरेडी सेकेंड स्टेप. एक सब्सटेंस है जो ऑलरेडी प्लाज्मा में भी है और प्लेटलेट्स भी रिलीज करता है, उसका नाम है फिब्रिन स्टेबलाइजिंग फैक्टर. अगेन फैक्टर बोला तो ये प्रोटीन है, इट्स अ ग्लोब्यूलिन, नॉर्मली प्लाज्मा में भी होता है और प्लेटलेट्स भी रिलीज करता है. दिस एज द नेम सजेस्ट फिब्रिन स्टेबलाइजिंग, मतलब ये इस फिब्रिन के स्ट्रक्चर को स्टेबलाइज करेगा. Now, before fibrin stabilizing factor can have an effect on the fibrin fibers, उसको खुद को भी तो activate करना होगा ना. So first it has to get itself activated. So who will activate it? The thrombin. The thrombin that causes the fibrin formation. So thrombin, again I'm showing you thrombin. Where is, okay. This thrombin will help. This thrombin is converting fibrinogen into monomer. This thrombin is also going to activate my fibrin stabilizing factor. Okay. Then this activated substance operates as an enzyme. It acts as an enzyme to cause covalent bonding between more and more fibers, और फिर यहाँ पर ऐसी ऐसी क्रॉस लिंकेजेस भी शुरू हो जाती है. This is how the cross linkages was also starts. And now this meshwork, this entire meshwork is a strong meshwork. This is a strong meshwork. And this is how the blood clot is formed. Let's see the blood clot. The clot is composed of a meshwork. अब इसमें क्या है, इस mesh इसको हमने clot बोला है. अब इस clot के अंदर क्या क्या चीजें होती है? The clot is composed of fibrin fibers running in all directions. As you can see, fibers ऐसे ऐसे क्रॉस लिंक्ड हो गए एक तरीके से, और एक फिब्रिन फाइबर बन चुका है. इसके साथ में इसमें और भी होते हैं. क्या चीजें होती है इसमें? ब्लड सेल्स होते हैं, प्लेटलेट्स होते हैं, एंड ऑफ कोर्स द प्लाज्मा विल बी देयर. So this is how a blood clot is formed. Um, let's see the clot retraction part. What does this mean? So within a few minutes after a clot is formed, अब आगे की step, जब clot बन चुका है complete strong, it begins to contract and usually expresses most of the fluid from the clot within 20 to 60 minutes. The fluid expressed is called as serum because all its fibrinogen and most of the clotting factors have been removed. In this way, serum differs from the plasma. Serum cannot clot because it lacks these factors. तो जब ये clot बन जाता है, तो इन हिंदी व्हाट आई विल से कि ये अपना पूरा पानी निचोड़ लेता है, ठीक है. तो जो या फिल्टर कर लेता है व्हाट वी कैन से, और जो फिल्ट्रेट बचा है नीचे उसको हम बोलते हैं सीरम. अब इस सीरम में कोई भी फैक्टर्स नहीं है, कोई भी क्लॉटिंग फैक्टर्स नहीं है, और दिस इज व्हाट इज द डिफरेंस बिटवीन द प्लाज्मा एंड सीरम. प्लाज्मा के अंदर वी हैव ऑलरेडी सीन, प्लाज्मा मतलब ब्लड के अंदर जो भी फ्लूइड है, ये ब्लड वेसल के अंदर जो भी फ्लूइड है उसको हम प्लाज्मा बोलते हैं. दिस पार्ट, इसमें क्लॉटिंग फैक्टर्स है, इसमें प्लेटलेट्स है, इसमें आरबीसी है, इसमें डब्ल्यूबीसी है, सब कुछ है. बट जब एक मेशवर्क बनता है और जब वो फिल्ट्रेट निकालता है श्रिंक होके, उस फिल्ट्रेट में कोई भी सेल्स नहीं होते, कोई भी क्लॉटिंग फैक्टर्स नहीं होते हैं, एंड दैट फ्लूइड इज नोन एज सीरम. This is how you differ plasma and serum based on the clotting factors. Clotting factors are not present in the serum. Hence, serum can never coagulate anything. Serum can never coagulate anything because it does not contain any clotting factors. Next, platelets are necessary for clot retraction to occur. अच्छा, अब ये जो श्रिंकेज हो रहा है इसमें भी प्लेटलेट्स हैज अ रोल. Therefore, failure of clot retraction is an indication that the number of platelets are also low. Electron micrographs of platelets in blood clots show that they become attached to fibrin fibers in such a way that they actually bond different fibers together. Furthermore, furthermore, platelets entrapped in the clot continue to release procoagulant substances. One of the most important is fibrin stabilizing factor. ये हमने already पढ़ चुके हैं. So this is how the story runs. Next, we will see the positive feedback and the different pathways of it in the next.